Hello everyone. Have you ever heard developers say, "It works on my machine but not on production"? This is one of the most common problems in software development. Different operating systems, different libraries, different software versions, all of these can break an application when moving from one environment to another. Docker solves this problem by packaging everything an application needs into a container. In today's video, we'll understand Docker from absolute basics. We'll cover what Docker is, important Docker commands, Docker architecture, Docker workflow. By the end of this video, you'll have a solid foundation of Docker. Let's get started. What is Docker? Let's first understand what Docker actually is. Docker is an open-source platform used to build, package, and run applications inside containers. Think of a container as a portable box. Inside this box, we package application code libraries, runtime dependencies, everything required by the application. Because everything travels together, the application behaves the same way everywhere. Whether you run it on Windows, Linux, Mac, cloud server, the result remains consistent. Now let's understand the major Docker components. First is Docker Engine. Docker Engine is the core runtime that builds and manages containers. Next is Docker Image. An image is like a blueprint or template containing everything needed to run an application. When we start an image, it becomes a Docker container. A container is simply a running instance of an image. Then we have Docker Registry. Registry stores Docker images. Docker Hub is the most popular registry. Next comes Docker Volume. Volumes help us store data permanently. Even if a container is deleted, the data remains safe. Docker Network enables communication between containers and external systems. And Docker Compose helps us run multiple containers together using a single configuration file. Now, why is Docker so popular? Because containers are lightweight, portable, fast, isolated. Docker is heavily used in microservices, DevOps, CI/CD pipelines, cloud applications. Important Docker commands. Now that we know what Docker is, let's learn the most important Docker commands. Think of Docker commands as tools that help us manage the entire life cycle of applications. The first command is Docker build. This command creates a Docker image from a Dockerfile. Whenever we want to package an application, we use Docker build. Next is Docker run. This command starts a container from an image. Image is the blueprint. Container is the running application. Then we have Docker PS. This command displays all running containers. Whenever you want to check which containers are active, use Docker PS. Next command is Docker stop. As the name suggests, it gracefully stops a running container. If you need to restart a service or free resources, Docker stop is used. Another important command is Docker rm. This command removes containers. For images, we use Docker rmi. Docker also provides commands for storage management. Using Docker volume create, we can create persistent storage. Using Docker volume ls, we can list all volumes. And Docker volume rm removes volumes. There are also inspection commands. Docker inspect gives detailed information about containers. Docker stats shows real-time resource usage such as CPU and memory. As you continue learning Docker, these commands will become part of your daily workflow. Docker architecture. Now let's understand how Docker works internally. Docker follows a client-server architecture. There are three major components. The first component is the Docker client. This is where developers interact with Docker. Whenever we run commands like Docker build, Docker run, Docker pull, we are actually communicating through the Docker client. The second component is Docker daemon. Docker daemon is the heart of Docker. It receives commands from the client and performs actual operations. The daemon manages images, containers, networks, volumes. The third component is the registry. The registry stores Docker images. If an image isn't available locally, Docker pulls it from the registry. The workflow is simple. Step 1. Developer runs a command. Step 2. Docker client sends the request. Step 3. Docker daemon processes it. Step 4. If required, Docker daemon downloads images from Docker Hub. Step 5. Docker daemon creates and manages containers. You can think of the Docker daemon as the manager that controls everything happening behind the scenes. So let's quickly recap everything we learned. Docker is a containerization platform that packages applications and dependencies together. Docker images are templates. Docker containers are running instances of those images. Docker commands help us build, run, inspect, and manage containers. Docker architecture follows a client-server model involving Docker client, Docker daemon, Docker registry. The Docker workflow is Dockerfile image container running application. And Dockerfile is the blueprint used to create Docker images. These concepts form the foundation of Docker and are essential for DevOps, cloud computing, and modern software development. In upcoming videos, we'll go deeper into Docker networking, volumes, Docker Compose, Docker Swarm, and Kubernetes. If you found this video helpful, don't forget to like, subscribe, and share it with other learners. Thanks for watching, and I'll see you in the next video.